Alright, what's up guys? In this video we're going to pick up with some complex analysis. We're going to be talking about complex functions. So we're asked to find the real and imaginary parts of the given complex function. So we're given f of z is equal to z bar squared all over z. And they tell us here that z is equal to x plus iy, where x cannot equal 0 and y also cannot equal 0. So all the z bar is the complex conjugate of z. So the complex conjugate of z in this particular case, well, if z is x plus iy, well, then the complex conjugate is going to be x minus iy. So that's our complex conjugate. Let me write that down right quick. Okay, so we want this in rectangular form, basically. So let's begin by sticking in the information. So we got z bar squared all over z. So it looks like we'll have x minus iy. Don't forget it's being squared. And then we're just dividing all of that by x plus iy. Now let's multiply both the numerator and denominator by our complex conjugate, basically, which was x minus iy. So if we do that, we'll just have x plus iy. I'm sorry, not x plus, x minus iy. Actually, I'll move over here. X minus iy. Don't forget that's being squared. And then I'm just going to multiply that by x minus iy. And I'm going to multiply my denominator by x minus iy. So we got x plus iy multiplied by x minus iy. And we'll need to simplify here. So x minus iy squared times another x minus iy is x minus iy cubed. So we'll get x minus iy cubed. And we want to expand that out, and we can use the perfect square formula for that. So let me just quickly remind you of what that is. So remember that the perfect square formula, let's say I have a minus b, and let's say I'm cubing that. Well, the perfect square formula says I'll get a to the third power minus 3a squared b plus 3ab squared minus b cubed. That's going to be our perfect square formula. So we're going to apply it here. So we get x minus iy cubed, and it looks like we'll get x cubed minus 3x squared iy. It looks like we'll get plus 3x. This would be this would be iy squared. And then we'll subtract that from iy cubed. Now remember that in complex analysis, remember that I squared is equal to -1. So after applying this perfect cube formula here, we can kind of clean this up a little bit. So let's clean up this other side over here. So we got the minus 3x squared iy. Well, that's minus 3x squared iy. And then the 3x multiplied by iy. That's negative 3x y squared. Then we put everything together, so we'll end up with x cubed minus 3x squared iy minus 3xy squared plus iy cubed. And the reason why I rewrote it that way is because once we get down to the end, we're going to separate the real part and the imaginary part of the complex function, because we want it in the rectangular form, or we want it in the form z is equal to a plus bi, basically. So that takes care of the perfect cubing that we needed to do for that part. And then the last part is just x plus iy multiplied by x minus iy, which was the complex conjugate. And in that case, we just simply get x squared plus y squared. So let's identify the real part here. So we'll denote the real part RE, and I'll put f of z on the inside here. And so the real part in this case would just be x cubed minus 3x y squared all over x squared plus y squared. That'll be the real part. In the imaginary part, we could just use the abbreviation im, and since it's a function of z, I'll just write im f of z. And our imaginary part, well, we can just write that as negative 3x squared multiplied by y plus y cubed all over x squared plus y squared. Okay, so now we've separated those. So when we write a final answer, we're just going to write it in the form z is equal to a plus bi, basically. So let's go ahead and write down our answer on another sheet, and I'll post the solutions to this, of course, so you can see it. All right, final answer. Okay, so we're going to write this as x cubed minus 3x squared y, or 3x y squared, excuse me, all over x squared plus y squared. And that's the real part, and then it'll be plus. And if you want to put a minus there, that's fine. I'm just going to use a parentheses and write it as minus 3x squared y plus y cubed. I'm going to close that up, by the way. And all that's going to be divided by x squared plus y squared. And then we'll tackle on our I over on the other side there. And that's the answer. So that's how you find the real and imaginary parts of a complex function. Okay, well, hopefully that made sense. If you haven't seen complex analysis in a while, it might be a little bit of a brain teaser, but pretty straightforward process. Okay, so let me know if you guys got any questions about it. We'll talk about it in greater detail. I'll see y'all next time.